good afternoon, everyone. This is Shweta Singh, and I welcome all of you to Q&A session. So, am I audible? First, let me know. Ragvi,
Yes, ma'am.
who?
Audible. Yes, ma'am.
I'm audible. Who's there? Devi. Okay. So, I believe we haven't covered chemical equations, how to write chemical equation and how to represent it. Have we done this before?
Yes, ma'am. We should
Okay, sure.
start from balancing chemical equations.
Okay, so we need to start the balancing of chemical equation. So let's take you back to the balancing part. But I think I should tell you once all the rules once again. Okay, just for the revision purpose, let's see. So I'm just showing you the recap, what we did in the last session. So when I give you this question, reactants are written on which side and products written on what which side?
LHS and products are RHS.
Very good. Next one. Reactants and products are separated by.
Arrow mark.
Exactly, they are separated by an arrow. Fine. Then two or more reactants or products are separated by.
Plus symbol. Plus symbol.
Exactly, that is plus symbol. Then conditions mentioned. Where do we
On
mention the
arrow.
condition? Exactly, on the arrow. And dash of reactants and product to make reaction more informative.
We should
What do
write
we
the
write?
states.
Exactly, Ragul. We should write the states of matter, physical states of matter to tell, okay, so that these are the reactants, two reactants, and if I have more than two products, then also I will separate them with the help of plus sign. Okay. Then we talked about the symbols of the physical states and other symbols. So, solid state, what symbol do we use?
Small s. Small s.
Small s, and that too in bracket. Liquid,
Small l.
gaseous.
Small g in bracket.
Okay. Wait, Joven, will you tell me for aqueous state?
A small AQ.
Okay. Then Devi, will you tell me about the heat symbol for heat? What do we use?
A triangle.
Exactly, we use triangle. Evolution of gas, tehine, right?
Is it an aparo, mom?
Sorry?
Is it an aparo, mom?
Yeah. Upright arrow. Formation of precipitate, Ragvi.
Downward arrow.
Downside arrow. Okay, so here we got all the symbols, and now we had to learn how to balance the equation. Let me take you to those slides where we have to balance the equation. Fine. So here we are with the topic balancing equation. I know you know very well this thing, but I am going to share a method with you which is foolproof. It means if you get stuck anyhow in the first method, you can go for the second method. We will look for it. So prerequisite for this session, we should know about the law of conservation of mass. I believe everybody remembers law of conservation of mass we did in class 9th. But if anyhow you forgot, we have to see it today itself, right? So I'm not going to discuss it right now because we will start with the law of conservation of mass itself. Okay, coming to the balancing part, definitely you get question on balancing, and it is very important because whenever you are solving any numerical related to the reaction, we call it stoichiometry, balancing is required. So when you move to class 11th and 12th, you need to write balance equation, then only you can solve the problems. Okay, so that is the importance of balancing equation. In your class you can get directly 1 to 2 marks question from the balancing. Fine. So in this session, we are going to see how to balance chemical equation and quantitative information from balanced chemical equation, which what are the informations that we get from a balanced chemical equation. So these things we need to cover in this particular session. Okay, so let's start with this balancing chemical equation. Okay, so as I said, law of conservation of mass is the basis of balancing equation. Now, first of all, tell me who gave this law? Name of the scientist who gave the law of conservation of mass? Anyone? Come on. We started in class 9th, remember? In NCERT itself, the name of the scientists were given in front of every law. Ragul?
Lavoisier.
Sorry?
I don't know the correct name, but I remember Lavoisier.
Yeah, actually, the name of the scientist is Lavoisier. Okay, so Lavoisier gave the law of conservation of mass. And can Alan tell me what is this law about? Yes, Alan? Any idea?
Mass can neither be destroyed nor created.
Exactly, mass can neither be created nor be destroyed. It basically during a change, the total mass remains constant. It means what? That if I take the sum of the masses of the reactants, that would be equal to the sum of the masses of products, right? So you can get direct question to state the law of conservation of mass. And if I'm saying that A and B are my reactants, then total mass of the A and B, that will be equal to the mass of AB. We can take one example here, right? We can take one example here. Just give me a second. Yeah. We can take C plus O2 giving you CO2. Now tell me, what is the mass of molar mass of carbon? Mass of carbon? Anyone? Okay.
1.
Sorry?
1.
1. Okay, so here is one advice to you. Please do remember the atomic number and masses of first 20 elements. Very much required for chemistry. Just for first 20 elements, that is something you need to do. Okay, will you do that? That will be helpful for you only. Okay, so
Ma'am, is it 16? Ma'am?
no, dear, no, it's 12 gram.
Ma'am, is it 12? Oh,
Yeah, it's 12 gram. And if I take the molar mass, and if I take the mass of one atom, I have to write it 12U. Okay, I will write 12U. Okay, what about oxygen?
16.
16.
16. So what will be the mass of O2?
16, ma'am.
O2. 16 is the mass of one atom.
32.
32. So for 1 mole, I'm going to write 32 grams. Okay. So can you tell me the mass of CO2 now? Mass of CO2?
44. 44.
Exactly. So
44.
12 gram for carbon and 32 gram for oxygen, it is going to be 44 gram. So if I add the masses of carbon and oxygen gas, then what would be the total sum of this? This is going to be 44 only. Right. So this is what the sum of the masses of the reactants will be equal to the sum of the masses of the product. That is the law of conservation of mass, that mass can neither be created nor destroyed in a chemical reaction. That is total mass of the elements present in the products has to be equal to the total mass of the elements present in the reactants. Okay, I hope you understood this part. Everyone? And why is it important? Why is it important? Because this is very common question, that this is the basis of balancing chemical equation. Your chemical equations are balanced on the basis of law of conservation of mass, 1 mark question. Okay, I will move ahead, but before that, I have a question here. We studied this law in class 9th, that law of conservation of mass says that mass can neither be created nor destroyed. Do you know any drawback of this law? Limitation of this law? Where this law doesn't hold good, or it is not obeyed? Any law, any example, do you know? It's not 100% correct statement. Later on, when we discovered new things, we got to know, okay, this doesn't hold good every time. Do you know where does it not hold good? Nuclear reactions. Right? The nuclear reactions are the limitation where this law is not obeyed, because during the nuclear reactions, some of the mass gets converted into energy. You must be knowing E is equal to mc squared, the equation given by the Einstein, right? E is equal to mc squared. So some of the mass gets converted in to energy during nuclear reaction. So there, this law is not obeyed. Am I clear?
Yes, ma'am, clear. Yes, ma'am.
Okay,
Yes, ma'am.
fine. So now let's move on to the balancing part. How do we balance? So here I have a reaction between zinc and sulfuric acid giving me zinc sulfate and hydrogen gas. Fine. So when I write this, I have to write Zn plus H2SO4 giving me ZnSO4 plus H2. Can someone tell me when I wrote it like the zinc plus sulfuric acid, when I wrote their name, this type of equation is known as
Third
the
equation.
exactly, we call it word equation. Zinc plus sulfuric acid giving you zinc sulfate plus hydrogen. That is word equation. And this is your chemical equation. Now, whether it is a skeletal equation or balanced equation, skeletal means we have to
Balanced.
check. Yeah, so you know well that it is balanced equation. But when I have to see whether it is a skeletal, or I can say unbalanced equation, or it is balanced equation, to check that, I have to see, are masses on the both sides for each element equal or not? To find out whether the mass of zinc is same on both sides, whether the mass of hydrogen is equal on both sides, or mass of sulfur or mass of oxygen are equal on both sides, I can simply check the number of atoms. If I have same number of atoms on both sides for each element, it means the mass will be also equal, isn't it? Don't you think so? If
Yes,
I
ma'am.
simply check,
Yes,
if I
ma'am.
simply check number of atoms, if they are equal on both sides for each element, I would say that, okay, it's a balanced equation, because then their masses also be equal. Okay, so let's check whether it is balanced or not. So I am going to draw a table here. Here I will write element, number of atoms, and then number of atoms. This is on the reactant side, and this is on the product side. Okay, so first let's see zinc. Here we have one atom. On the product side also we have one atom. It is balanced. Okay, then coming to the hydrogen, let's find out for hydrogen. Hydrogen, number of atoms on left hand side, we have two hydrogen atoms. On the right hand side, again we have two hydrogen atoms, balanced. Okay, coming to the sulfur. For sulfur, I have one sulfur on left hand side and one sulfur atom on right hand side, balanced. Then oxygen, on left hand side I have four oxygen atoms, and on the right hand side I have again four oxygen atoms. It means all the elements have equal number of atoms on both sides. So it is a balanced equation, right? It is a balanced equation. That is true statement here. Okay, so as the number of atoms of element is the same on both sides of the arrow, hence it is a balanced equation, and this is according to law of conservation of mass. Okay, let's pick up another equation here. I have Fe plus H2O gives Fe3O4 plus H2. That is the equation. Do you think this is a balanced equation?
No, ma'am.
Yes or no? No.
No,
Which
ma'am.
element is not balanced here? Which element is not
Oxygen.
balanced? Oxygen is not balanced. Okay. Only oxygen?
Fe.
Fe.
What is Fe?
Iron.
Iron, right. So iron and oxygen both are not balanced here. So what is our first step? How to balance a chemical equation, right? Balancing chemical equation. So our first job is to put them in box. So whenever I have to add some number, I am going to add in front of the box. I can't add here Fe. I can't write down subscript as I have written over here H2. I can't write subscript here. I have to add number here only in front of boxes. Okay. So I made the box and then I will make a table here. So list the number of atoms of different elements. We made the box and now I'm going to list the number of atoms for each element in the boxes. So again, element, number of atoms. This is for LHS and this is for RHS. Let's note down. Our first element here is iron. So what should I write here? Tell me.
1.
1.
1. Right hand side?
3. 3.
3.
3. Okay. Next element is hydrogen. So
2. 2.
2. That
2.
side?
2.
Again 2.
Two.
Then oxygen? Oxygen?
1.
1.
1.
Yes.
That's it.
And
4.
that side?
4.
4. So definitely they are not
Four.
balanced. Yeah, definitely they are not balanced. So what should be our next step? This is our first step where we listed the number of atoms of different elements, but we did it after putting them in the box. Now what should be our next step? We are going to look for the element which has highest number of atoms. So what do you think? Which one is having the highest number of atoms? Oxygen,
Oxygen.
right? Yeah. So total it has 4 that side and 1 this side. So we have maximum number of atoms for oxygen. So our job is to first balance the number of atoms for oxygen. Fine. So this is our step 2 where we will look for the start balancing the compound that contains maximum number of atoms. Right. So when we see the compound having maximum number of atoms, which one is that? Compound? Tell me.
Fe3O4.
Exactly. Now our compound is our compound here is H2O and Fe3O4. Can I say that iron and H2 both are compound? Iron and H2O,
No,
can I? No.
No, ma'am.
No, ma'am.
Exactly. Why? Because this is having only one kind of atom and same with the hydrogen also. So it is molecule of hydrogen element and this is atom of iron metal, or I can say iron element. Fine. So what do you think? So I'll start with oxygen because it has got 1 and here 4. So what shall I do to balance? Tell me. Let's balance oxygen.
We should multiply 4 in the LHS.
Exactly. So if I'm multiplying here on the LHS side with 4, so it means I should here write 4,
Yes.
isn't it?
Yes,
Okay,
ma'am.
I did so. That is 4. Now my oxygen atoms are balanced. Now coming to the iron. Iron 3, this side, and here 1. So what shall I do?
Multiply 3.
Multiply 3 this side. So it means I should write 3 here. Please mute yourself because you understand well. Okay. So now my job is done here. But while doing so, is there any change in the atoms? Number of atoms? So 3, fine. Here Fe, 3, fine. Now hydrogen, LHS side, how many hydrogen atoms are there?
8 atoms.
8. 4 into 2. Now it has become 4 into 2. So it has become 8. And here it is only 2. So what shall I do? I should multiply by 4. So hydrogen atom here. So I got 4 num. Am I clear with all these steps?
Yes, ma'am. Yes, ma'am.
And here oxygen 4,
ma'am.
fine, everything is done. Here 4 and Fe, no change. So now I got my balanced equation, that is 3Fe plus 4H2O, giving you Fe3O4 plus 4H2. So we started with the compound with having the maximum number of atoms. Okay, so any doubt at any step here? Please let me know if anybody has got doubt.
No doubts.
Great.
No doubts.
Okay, so here we come to the step 3. The physical states of the reactants and products are mentioned along with their chemical formulae, right? So in a balanced equation, their physical state should be mentioned. And this is quite common silly mistake which students do. They simply balance, they don't write the physical state, but that's the part of a balanced chemical equation. So you know well what should we write for each physical state. So our balanced equation is 3Fe solid plus 4H2O, that is in steam form. So I'm writing G here, gas, right? It is in steam form, and giving you Fe3O4, that is solid, and hydrogen gas, 4H2 hydrogen gas, or I can simply put upright arrow also there, isn't it? I can show, because here a gas is evolving, so I can show upright arrow also here. That's the balanced equation, and I hope nobody has got doubt, because we will be solving few questions also there. Okay, so now coming to the fourth step. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reaction are indicated above or below. You can use above or below the arrow space in the equation. For example, carbon monoxide, that is gas, plus 2H2, again a gas, reacts to give you methanol, that is in liquid state, at 340 atmosphere. No, Raghul, yes. So you don't have to memorize it actually. You know what? You know that metals exist in solid state except mercury. So if there is any metal, we can simply write solid. Mostly your water is in liquid state. But here I know the reaction, and once you move to the metals and non-metals chapter, you will also come to know when iron reacts, it reacts with steam. So you will yourself write gas here. Okay. So 340 atmosphere, that's the pressure at which the reaction is happening. Again, another reaction. This is the reaction for, can anybody tell me? 6 CO2 plus photosynthesis. So exactly. So for photosynthesis, you need sunlight and you need chlorophyll. They are essential conditions. So we are writing above and below the arrow, giving you glucose and oxygen. Okay. So we did 4 steps how to write the reaction. Now I'm showing you another method, that is algebraic method. If in any case you are not able to balance by hit and trial method, what we just saw, that was hit and trial method. I'm going to show you another method here. Okay, let's take the equation Fe plus H2O, giving you, what was the reaction? H2. Fine. So now I'm showing you another method. How can you do it? It is little bit longer method, but it will help you when you are stuck while balancing. So our first step, I would really appreciate if you can do these steps with me in your notebook. Okay. Follow me in your notebook. Write down. Please write down this equation Fe plus H2O giving me Fe3O4 plus H2. Have you done? Okay, shall I continue with the next step?
Yes, ma'am.
Okay, so now do one thing, write A, B, C, D in place of whatever number you write, whatever digit you write over there, you just simply write A, B, C, D. So my job will be to find out the values of A, B, C, and D. So I'll get the balanced equation. So I simply wrote A, B, C, D. Okay. Fine. Now I'm going to use the law of conservation of mass, or simply I can say I can use the law of conservation of atoms. So number of atoms for each element should be same on both sides. So first I'll pick iron. Okay, so according to this, okay, one thing more, like A, B, C, D, whatever we wrote, no, that they are known as a stoichiometric coefficient. We call them stoichiometric coefficients. Do remember. Okay, so for iron, what do you think? How many atoms are there on the left hand side?
One atom.
One?
One
Say
atom.
again.
Yes, ma'am.
A number of atoms, isn't it? You have Fe and A is there, the stoichiometric coefficient. It means total number of atoms will be A. That should be equal to how many atoms this side for iron?
Three.
Is it 3 or 3C?
3C.
Clear? No, it is 3C, right? So you have to multiply, no, the way you were doing when I write 2H2. So you say there are 4 hydrogen atoms, isn't it? So similarly, I'm saying that there are 3 C atoms. So this is my first equation where I said A is equal to 3C. Why? Because if this equation is following the law of conservation of mass, then number of atoms here should be equal to number of atoms right hand side for iron metal, right? I hope you understood the concept behind this equation. If anybody has got doubt, please ask me right now. No one has got doubt? Great. Okay, so now let's pick up another element, that is hydrogen. Can you tell me number of hydrogen atoms on left hand side?
2B.
Yes, it's 2B is equal to
2D.
2D. So I can just simply cut this off and it will become B is equal to D, and that's my second equation. Okay, now coming to the oxygen. Yes. Oxygen.
B is equal to
B is equal to
4C.
Yeah, it is 4C. So that's our third equation. So now with the help of these equations, I'm going to find out the value of each one of them. Okay, so next, this was the second step. Have you written all these?
Yes, ma'am.
Yes, ma'am.
Okay, so this was our second step. First step, A, B, C, D, and then second step, applying the law of conservation of mass for each of them. Now the next step, suppose you need to suppose here, suppose A is equal to 1. You will take A is equal to 1. So in any equation, while balancing any equation, you have to suppose that A is equal to 1. So if A is equal to 1, what will be the value of C?
1/3.
Exactly, because
By
C is A by 3, so it is going to be 1/3. Okay. If C is 1/3, what should be the value of B according to equation 3?
1. Oh, sorry. 4 by 3.
4
4
by
by 3.
3. Okay. And then what should be the value for D?
4 by 3.
4 by 3. So we got value for each A, C, B, and D. Anyone who didn't understand from where we got these values or B or C, please do ask me right now. And if it's clear to everyone, show me thumbs up.
Ma'am, how did we reach C?
C. Okay. So for C, look at the this equation. We took A is equal to 1. So C will be equal to A by 3, right?
Yes.
Okay. Anyone else got doubt in anything? I got thumbs up from Ellen. I think Joven also understood this part. So show me your thumbs up. What about others? Devi understood. Ragvi understood. Tehin understood. Ragul also understood. Okay, so we got this. But one problem is here. Okay, let me write it, rewrite this. A is equal to 1, B is equal to 4 by 3, C is equal to 1 by 3, and D is equal to 4 by 3. One problem is here that there are fractions, and we don't write fractions as the stoichiometric coefficients. So what should we do? We should multiply with the smallest number so that we get the whole number there. So what do you think? With which number shall I multiply all of them so that I get whole number?
Ma'am, for B, multiply with 3, ma'am.
Exactly. So I should multiply all of them with 3. So A comes out to be 3, B comes out to be 4, C 3, and D is equal to 4. And I got the values. So it became 3 Fe plus 4 H2O, giving you
C is equal to 1.
sorry, C is equal to 1, my mistake. C is equal to 1 and here 4H2. Understood how to do this method, how to apply this method?
Yes, ma'am, understood.
Okay. So this is a bit longer method. That's why I'm saying first apply hit and trial. If you get stuck at any step, then you go for this method. Then this is going to help you out. Okay. Fine. So this was the method, and I'm coming back to the next slide now. Before you attempt this question, there's a Google form shared with you. Can you see in your chat box?
Yes, ma'am.
Please do fill up that Google form after the class. Don't leave the class, without filling the form. Okay, now coming to this question. Which of the following chemical equations represents a balanced chemical reaction equation? Simply, which one is balanced chemical equation? Okay, so I want you to answer in the chat box. I'll see who will answer this question. And before answering, okay, Raghul, you were quite fast. You didn't actually hear the rule. I was going to say some rule here before writing the answer. Anyway, so you said D. What's wrong with A? Which element is not balanced here in A?
NO3, ma'am.
NO3. Okay, so we have one NO3 and here we have two NO3. So means nitrogen and oxygen atoms both are not balanced here. Okay, Tehin, I would like to know how many oxygen atoms are there on the right hand side in the first equation? I can't hear you.
Can you hear me now, ma'am?
How many?
Can you hear me now, ma'am?
Yeah, I can
two,
hear you.
Two, ma'am.
Two oxygen atoms. Okay, let me verify with Devi. Devi, do you think on the right hand side we have two oxygen atoms?
No, there are 6.
Yes, there are 6 oxygen atoms, Tahin. How do we know this? See, NO3 whole twice. NO3 means this whole twice. So 3 to just 6. Understood?
Yes, ma'am.
Okay. And how many nitrogen atoms?
Nitrogen atoms.
Yes.
There's two nitrogen atoms, ma'am.
Very good. Two nitrogen atoms. Very good. Fine. So coming to this, so this is not balanced. This is not our answer. Coming to the second one, which element is not balanced there?
Chlorine.
Copper.
Cl.
Cl. Chlorine is not balanced here. Copper, yeah, you can say so. Copper is also not balanced. So, Ragul, can you tell me how many copper atoms are there on the left hand side?
3, ma'am.
3 copper atoms. And how many chlorine atoms?
1. Oh, sorry. 6.
6. So, 2 copper atoms and 6 chlorine atoms. Okay. On the right hand side?
Copper atoms is 1, ma'am. And chlorine
Okay.
atoms are 6.
Chlorine atoms are 6. So can we, please mute yourself, mute yourself. Okay, so Jovin, can we say who gave the answer chlorine? Ellen, I believe you gave, no? Or Jovin gave? So you gave. So do you think that chlorine is unbalanced here? See?
Yes, ma'am. I feel it's unbalanced.
See, here we have 6 chlorine atoms, and here also we have 6 chlorine
Oh, I didn't
atoms.
see the number. Sorry.
Right? So the copper is not
It's
balanced
balanced.
here.
Yes.
Yes. Okay, so this is called, this is how we should attempt a question while we are practicing something, we are learning something. Then only you will avoid the silly mistake. Fine. So next one, coming to the next one. Yes, Ellen is saying, Raghavi is saying C. So it means Jovin also saying C. So do you think that C has no element which is unbalanced?
Yes, ma'am.
Exactly. So here barium 1, here also barium 1. Chlorine Cl2, here we have Cl2. H2, and here also we have 2 hydrogen. 1 sulfur, 1 sulfur. 4 oxygen atom, 4 oxygen atom. So yes, this one is balanced equation. So let's find out what's wrong with equation D. Yes? Which element is not balanced here?
Ma'am, hydrogen in the left hand side is 3, but the right hand side is 2.
Very good. Are you sure, Raghavi, we have 3 hydrogen atoms on the left hand side?
Yes, ma'am.
Anyone who want to say no to this answer? Anyone who disagrees with this answer? I disagree. Nobody? Now, Raghavi, tell me how many atoms?
Yes, 4 hydrogen.
Right, 4 hydrogen atoms on the left hand side, and only we have 2 hydrogen atoms on the right hand side. So definitely it's not balanced. Understood? Clear, everyone? So sometimes we think that we know these things, we can quickly attempt this question, but this is how we can go wrong. So please take your time, see carefully, and then only answer. Okay, so we need to do more questions, but we will carry on these questions in the next session. But before going, you need to attempt questions on the platform. Have you started attempting question on platform? Have you started? If not, please start if you got the login IDs, because then only I'll get to know how much have you understood, what topic shall I take with each of you for the need-based tutorials. And you will get that exactly if you think that, okay, I know this topic. Do you really know that topic? You'll come to know when you practice. So you have to go to the assessment. In the assessment, you have to go in the custom. Here it's not working. we'll see later. But anyway, in custom, you'll go to the science section. In science section, you will find the chapter. Which one? Chemical equations and reactions. In chemical equations and reactions, you'll go to the topic balancing chemical equation and then start attempting question from there. Okay, so try questions from your platform, but it will change your my score. The score you are getting, how much have you improved, it will affect those score. So that's why I will suggest you to go to the learning segment first. Get habituated to solve the question. You'll get hardly 4 or 5 questions for each topic. For balancing also, hardly 4 or 5 questions will be there, and they're static questions. They are not going to change your my score. Okay, so you can just start with practicing on the learning like this. Where is it? Learning segment. I missed it, no? Okay, I missed it. So in the learning segment, you will come and you can attempt the question there. So after attempting question over there, then you can come back to the practice and start attempting question. Then it is going to improve your score. Okay, understood? Yes or no? It means
Yes, ma'am.
no. Okay. Fine. So this is what we did today. We are going to solve many questions in the coming classes, coming up classes. And we started today the balancing chemical equation. And in the next session, we will find out what are the informations that we can get from a balanced chemical equation. After doing more examples, more questions, and the informations, we will move on to the types of chemical reaction. This is something which is actually very, very important for you. Okay, this is the part from where actually you get the question. Okay, so that's it for this session. Thank you, everyone. Any question here? Anything you want to ask? And if not, please fill that Google form and then leave. Okay, thank you, everyone.